Right everyone, next we are moving to the capacitors part 4. Okay, troubles in capacitor. So in this what are the troubles present in the capacitor? Two cases are possible. The first one is a open circuit, it may be short circuit. Two cases we have a trouble. So in the capacitor, in case of if it is open circuit or it is a closed circuit, both the cases capacitor is a useless. That means it is not useful in the practical applications. So that's what capacitor open and short circuit is not recommendable. So how to identify this open and short circuit? Everything we are discussing in this particular chapter. So a good capacitor very high dielectric strength. Whenever it is a very high dielectric strength, so good capacitor having very high dielectric strength. Okay. So whenever it is a very high dielectric strength, the resistance, the internal resistance of the particular capacitor, internal resistance will be 500 to 1000 mega ohm. Okay, then it is a good capacitor. For example, different type of capacitors we have. This is a case 500 to 1000. The capacitor, the material you're using, the dielectric media is a paper, maybe ceramic, capacitors. In case of electrolytic capacitor, it may be 0.5 mega ohm. This is a case for electrolytic capacitor. Okay, so this is about the internal resistances. Now in case if it is a short circuited, the capacitor is short circuited. What about the if it is short circuited, the internal capacitor value is 0 ohms. There is no internal capacitor. If it is open circuited, circuit, the internal resistance may be infinity. This is a case ideal. So that's what here open and short circuited, the internal resistance, if it is short, internal resistance is 0. If it is open, internal resistance is infinity. Then we are moving to the when these things are happened, how to check with ohm meter. That is our next topic. So checking capacitor with ohm meter. So first I will tell you the procedure, and then after procedure I will explain indications to whether capacitor is conducting the good position or it having some trouble. Okay, first we'll see the procedure to test checking. Okay, the first point, while you are checking the capacitor, you should be discharged, right? Discharge the capacitor before checking. That is the first point. So it should be discharge before checking. Okay, should be done. After that, second, make sure that voltmeter rating not exceed the working value of capacitor. For example, the capacitor is 5 volt. Okay, if it is connected to the ohm meter, in between, okay, so the battery we are using this ohm meter to working, that voltage not exceed the 5 volt. Okay, so not exceed rated voltage. Okay, that is the second thing you need to remember. Third thing, while you are while you are checking the capacitor, for example, capacitor connected in the circuit. For example, we have the capacitor in the circuit, right? For example, you want to check this particular capacitor. If you want to connect the ohmmeter here to this capacitor, one of the terminal, that means one of the terminal, maybe any side, we need to disconnect it, and then we can check with this particular ohmmeter. Got my point? That means while you are checking the capacitor, whenever it is connected to the circuit, one of the terminals should be open circuited, then it is disconnected from the circuit and then checking. Okay, that is also another thing. So if it is not disconnected, what will happen? This particular, if it is not disconnected, so this particular capacitor is counted. That means it is a parallel to the particular entire circuit. The resistance offered by this particular internal resistance offered by the capacitor is decreases. You may get wrong answers, right? So that's why you should disconnect it from the circuit. Okay, then you can measure. Okay, next fourth point. While you are checking the capacitor, this is a ohmmeter. So one person standing here, okay, is want to measure this capacitor checking. Okay, this person don't touch these wires, right? This person, if it is fingers are touching this particular wire, what will happen? It may this particular person resistance parallel with this capacitor, the value we are getting is decreases. Got my point? That means while you are measuring the capacitor, don't touch the terminals of ohmmeter or terminals of capacitor while you are checking the capacitor. Okay, got my point? That is the fourth point you need to remember. Don't touch the terminals. So while you are using the ohmmeter also, you can use the highest scale. Ohmmeter scale should be highest. So use highest ohm scale. Okay, from that the procedure is done. Once you got the procedure how to check what is the precautions you got, then we are moving to the observations. After everything is done, what are the troubles you found, we can discuss now. Okay, troubles. Okay, let us discuss that. The first trouble will be, for example, meter point. We have a meter, it is starting from 0, it is infinity. Some readings will be there in between. Okay, for example, the meter point immediately goes to practically 0. That means the pointer is shows here only practically 0, and stay there. The capacitor is short circuited. So whenever this particular resistance 0, whenever you are connected to the capacitor, you made that capacitor is a short circuited. You can conclude that capacitor is a short circuited, because whenever it is short circuited, whatever the internal resistance is 0. Okay, that is the first observation we have. Next, second observation. Second observation. So if pointer goes to low resistance side, so that particular point goes to low resistance side, that means the capacitor is charging. Capacitor is charging. So whenever capacitor is charging, wherever the pointer goes low resistance side, goes to low resistance side. Okay, that is indication. Then it is goes up. For example, then it is goes to low resistance side. When it is goes up, the reading less than the normal value. So some leakage in the resistor. So all of you got this particular point. So the second observation here, whenever the capacitor is connected to the voltmeter, the pointer goes to the low side. That means capacitor is charging. After that, it is up to the it is increases, but it is less than the normal value. Some leakage is present in the capacitor. So that is the third observation. Next, fourth observation. In the fourth observation, the pointer goes low to the low resistance side. So capacitor is charging, no problem. But it goes straight to infinity. The same thing, it is a capacitor is a pointer goes in the low side. But what will happen here? The pointer goes straight to infinity. So the pointer goes to infinity. Okay. In that particular case, capacitor is a open circuit. Capacitor is a open. Okay. So this is about the third case. This is a condition we have, but the pointer shows the infinity, so it is going to be open circuit. Right? Last observation: if the pointer first moves quickly towards the low resistance side, okay, the pointer low resistance side quickly, so it shows the capacitor charging, and then slowly this pointer slowly goes to infinity. This is a 0, goes to infinity. It shows the good capacitor which supposed to very large infinity resistance. So in that case, initially capacitor goes to pointer goes to low resistance side, and then it moves to slowly to the infinity side. So that is a good capacitor. The difference between this particular point and this particular point, it is a pointer shows in the low resistance side, and then it is immediately goes to the infinity side. In that particular case, it is open, but in this particular case, it is a first quickly show the low resistance side, and slowly it is reached to the near to the infinity point. That is a capacitor is a good capacitor. Internal resistance is infinity. Okay, these points are enough for the examination point of view. I gave a detailed discussion about this particular ohm meter checking process. Then we are moving to the next one, capacitor, charging up capacitor. This is also one of the important topic. So everyone listen carefully. So we are looking at the two capacitor, two circuits we have. The first case, the capacitor is not giving any supply. The capacitor is there is no charge in the capacitor. So now I'm closing this capacitor, this particular switch. What will happen? So the current will be flowing. The current will be flowing. So whenever a switch is closed, current will be flowing. This is the direction. That means it is a positive polarity. It is a negative polarity. The charge is formed. Okay. So whenever charge is formed, what is the time constant in that particular case? Time constant T is equal to RC. Resistance into capacitance, that is a time constant. So here R is a capacitance, resistance, and C is a capacitance. So whenever it is reaches to 5 time constants, whenever it reaches to 5 time constant, capacitor is a fully charged. Capacitor is fully charged. So whenever capacitor is fully charged, look at this particular graph. Initially it is 0. Whenever you are giving the power supply energy to the capacitor going to be increases. Whenever it is reached to the 63.2%, whenever 5 time constant, it is reached to the 63.8% of the full charge. 63% of the full charge. So capacitor is it is a time constant is 63.2%. So whenever it is known that capacitor is charged. So whenever this particular time constant is reached, we have to capacitor is charged completely. Then we are closed the switch. Whenever we close the switch, remove the voltage here. Whenever remove the supply voltage, capacitor is trying to discharge. This particular capacitor is trying to discharge. In that particular case, whenever capacitor is charged to to the fully charged. After that, capacitor is trying to discharge from the 100% to whenever it is reached to the 36.8%. 36.8% of fully charged, the value of 5 time constant, capacitor considered as a fully discharged. That means whenever 100% whenever it is reached to the 36.8% of that fully charged, then capacitor is a discharged, fully discharged. Okay, these are the points you need to remember. When capacitor is fully charged, whenever it is reached to the 63.8% of fully charged. Whenever capacitor is fully discharged, whenever it is reached to the 5 time constants of 36.8% as a fully charged value, then it is called as a fully discharged. Okay, so fully charged means here 100%. Here fully charged is mean that 100%. Okay, then the increasing and decreasing charge across a capacitor, whenever increasing and decreasing charge across a capacitor is found, then this time constant chart, it is increasing and decreasing both. So it is represented the rise and decay, that is the charging and discharging currents of capacitor respectively. So it is a charging, rising and decreasing, both it is represented in this particular graph. So everyone is clear about the capacitor charging, right? Then we are moving to the example problem based on the above discussion. So capacitor is given, the value is of 50 microfarad. The resistance value is given 40 kilo ohm. The potential difference is 400 volt. These are the parameters we have. They are asking to find out the first point, time constant. T is equal to RC. What is the R? 40K and C is a 50 micro. That will be equivalent to 2 seconds. Okay, what is the time constant? 2 seconds. Second one, the value of fully charged. Fully charged, the thing, but Q is equal to CV. What is the capacitance value? 50 into 50 microfarad or 50 into 10 power 6 into voltage is 400. That will be equivalent to fully charged 0.0126 coulombs. That is a fully charged. So the value is not 0.06, your value is 0.02 coulombs. Clear? Then third point, charge acquired one time constant. So charge acquired one time constant is 60, charge at one time constant 63.2% of fully charged. That is a fully charged is 0.02. That will be equivalent to 0.0126 coulombs. Look at here. Where we will reach this particular 63.2% at time constant is 1. Okay, 5 time constants. This is the 5 time constants. It reaches to the 100%. So got my point. 1 time constant they are asking the question here. So look at here. Charge acquired one time constant, that is a 63.2%. Next, energy stored in the fully charged capacitor. The fourth point is energy stored. Energy stored is equal to half CV square. So 1 by 2, capacitor is 50 microfarad, voltage is 400. That will be equivalent to 2 joules. Okay, with that this explanation is done. So everyone got the idea. So what is the charge acquired in one time constant? 63.2% of fully charged. Okay, what is the fully charged time constant? 5 time constant, 5T. Okay, then we are moving to the capacitors connected across AC source. So while you are looking at here, the capacitor in the AC source, we have a 2 cycles. One is a positive half cycle, other one is a negative half cycle. This is for AC. It may be current or voltage. So here connected AC supply, bulb is also connected to whether it is a charging or discharging, it is indication like that. So whenever it is a positive half cycle, the current will be flowing this direction, capacitor is a charging. Okay. In the same time, in the negative half cycle, the polarities are reversed, even though current will, polarities are reversed. So capacitors also change these polarities, plus and minus. It discharge the current. It's trying to discharge the current here. Okay, in this direction. In the both the cases, whenever it is a positive half cycle or negative half cycle, the light will be glow. In this particular light will be glow, irrespective of it is current direction, the lamp will be always glowing. So in that both the cases, capacitors are charging as capacitors are discharging, continuously it is taking place, alternating, right? Positive capacitor is charging, again once it is reached to the positive half cycle, and again whenever in the negative half cycle, capacitor is discharging. Everything is taking place from M to N, the current directions are reversed it. So this is in this process the lamp keeping a light, already I'm saying that, but whenever you are discussing about the what we call in the DC case, just now we discussed in the DC case, it allows some current, okay, but in case of good capacitor, in the DC case also, it won't allows any current, it blocks the DC. Okay, that's what you are saying, that it will be appreciated that no current, whether DC or can be AC, the capacitor behave the like a lamp always glowing in the both the cases with respect of the directions. So final conclusion here, the capacitor working in both AC as well as DC, but in case of good capacitor, it blocks the DC, it only allows the AC. That's what we are discussing in the next topic. In the next topic, capacitor reactance. So capacitor reactance means a good capacitor commonly blocks the DC. Good capacitor commonly blocks the DC. Okay, how can you say that whether blocks the DC or not? Capacitor, even though you are connected the AC supply, the just now we discussed in the positive half cycle we have charging, and the negative half cycle discharging. Even though positive half cycle charging, negative half cycle discharging, it offers some opposition to this particular current. Okay, particular charging, whenever it opposes a particular current with respect to the frequency, then that opposition you are call it as a capacitor reactance, that will be equivalent to 1 by 2 pi FC. Okay, this is the formula for capacitance. Now my question here, whenever you are connected the DC to the capacitor, what about the frequency of DC supply? 0. Whenever frequency of DC supply is 0, Xc is equal to 1 by 2 pi 0 C, that will be equal to infinity. Capacitor reactance is infinity. Already mentioned, capacitor reactance is the internally the capacitance opposes some opposition to this particular current flowing through the capacitor. This opposition is nothing but a reactance. So whenever opposition is infinity, what will happen? The capacitor is completely not allow the any current, completely not allow the any charging. That means capacitor is like opens, completely open. So whenever capacitor, even though don't get confused, and your understanding purpose, I am using the current word here, opposing. No, the capacitor won't directly current from the positive plate to negative plate. Once again I will repeat, capacitor not directly connected, electrically connected this particular plate and this particular plate. Internally dielectric media is present, current directly not flowing. So here charge is acquired and discharging, charging and discharging. That particular process, this particular capacitor reactance is opposes. Okay, so whenever it is opposes, I is equal to V by Xc. So V divided by what is Xc? Infinity. That means current is equal to 0. Whenever the current is equal to 0, it is called as a open circuit. The capacitor acts as a open circuit. Whenever in the DC condition, at steady state, all I am discussing about the steady state. In the DC condition, at the steady state condition, capacitor act as a open circuited. In the steady state condition, inductor, you are connected to the DC supply. I explained there in the inductor concept. Inductor act as a short circuited. Okay, these are the cases for the steady state. In the next chapter, in the second unit, transient response. In the second unit, third chapter, we have a tuned circuit. In that, I will explain the time constants, everything, including transient period and steady state period cases also. Then you will get the complete idea about that. With that, we are concluded our capacitor complete discussion. Thank you for watching. And then still we have a doubt, we can send a message in our app, Play Store in the app. Otherwise, we have a separate Telegram channel. We can ask any doubts related to our subject. Okay, thank you.